all, and welcome to the OSHA Fall Protection Handbook for Construction Activities. Today we're going to be reading the entirety of it and all the contents thereof. This is what the booklet looks like. This is for 2019 updates and regulations on OSHA fall protection regarding all kinds of construction. So we'll go ahead and start. I'm going to skip the contents directly into the first portion of this, which is what's new. General fall protection trigger height in construction. Starting January 1st of 2017, the general fall protection trigger height was lowered from 10 feet to 6 feet. Side guard systems. October 1st of 2017, the use of slide guards as the only or primary method of fall protection is prohibited. Here's the introduction. Falls from heights contribute to more deaths in construction than any other hazard. A fall can occur in a split second without any time for the worker to react. Using fall protection can mean the difference between life and death. What is fall protection? Ask 10 people what fall protection means, and you'll likely get 10 different answers. For many in the construction industry, equipment is the first thing that comes to mind. Guardrails, personal fall protection systems, or safety nets, for example. But fall protection is more than equipment. Fall protection is also what you do to eliminate fall hazards, to prevent falls, and to ensure that workers do not fall. And workers that do fall don't die. You can accomplish fall protection by doing the following. Ensure that everyone has a role to play in preventing falls. Identify and evaluate fall hazards. Eliminate fall hazards whenever possible, rather than using personal fall protective systems. Train workers to recognize fall hazards and how to protect themselves. Use appropriate systems and methods to prevent falls and to protect workers if they do fall. Inspect and maintain fall protection equipment before and after using it. Become familiar with OSHA, Oregon, fall protection rules. Why do we need protection from falling? We need protection because even if we are experienced with working in heights, we can still lose our balance or grip. We can slip, trip, or misstep and fall at any time. We may think that our reflexes will protect us, but we can fall before we have time to react, and we don't have to fall far to get hurt. What is your role in protection? Everyone involved in construction projects has a role to play in preventing falls. Employers prevent falls by planning to safely get the job done, providing the right fall protection equipment, and training all workers to use the equipment safely. Employees follow safe work practices, properly use fall protection equipment, and participate in training. Recognize fall hazards and unsafe practices. Know the jobs that increase the risk of falling, and understand how to eliminate and control exposure to fall hazards. General contractors take reasonable steps to provide for frequent and regular inspections of the job site to identify hazards and to eliminate or control employee exposure to them, including fall hazards. Architects and engineers educate employers about hazards that could expose workers to falls during each phase of construction project. When designing buildings and structures, consider fall protection and other safety needs for those who will do the construction work and those who will eventually need to perform maintenance. Building owners and managers ensure that those who do exterior construction or maintenance work know how to protect themselves from falls, are aware of the location of installed anchorages, and know how to use their fall protection equipment. Maintain engineering documentation or permanently installed anchors for further references. Equipment manufacturers ensure that fall protection equipment meets OSHA and American National Standards Institute (ANSI) safety requirements and protects workers when they properly use it. Warn workers through instruction manuals and equipment labels about the danger of improperly using equipment. Lawyers review your client's construction bids to ensure they comply with Oregon OSHA requirements. The document should clearly state the client's responsibilities for protecting workers from falls and for identifying controlling hazards that cause falls. Here we have a nice little illustration of fall protection that is not being used. You can see these people are not using fall protection. Part 1. Falling. Truths and consequences. There's a graph here as well, which I'll have to show you. How Oregon construction workers fall. Table 1 shows that falls from ladders account for nearly half of all disabling falls. Causes may include selecting the wrong type of ladder, using a damaged ladder, improper use, and incorrect placement and setup. So there's some numbers here. Type of fall from ladder. There's over 344 falls from 2013 to 2015. The percent is 44.4% of all injuries in that same year period. Falls from the roof make up 119 of these falls in that period, or 15%. Other falls seem less common. Vehicle, scaffolding, structure, downstairs, lower level, and the least common is from building to a lower level, which only accounts for 2 injuries between 2013 and 2015. Part 2, preparing to prevent falls. There's also another picture here. You can see this man is not harnessed off, and that typically would be an OSHA violation, so they're illustrating that for us there to make sure we understand what is not safe. Part 2, preparing to prevent falls. Make fall protection part of your safety program. Prepare a safety policy. Designate competent persons and qualified persons. Duties and responsibilities of competent and qualified persons. Summary. Preparing to prevent falls. Make fall protection part of your safety program. And ensure that everyone has a role to play in preventing falls. Most successful programs have the following elements. Management commitment. Business owners and managers are as committed to workplace safety as they are to any other critical part of the business. Accountability. Supervisors and employees are held accountable for following safe work practices. Employee involvement. Employees are involved in day-to-day effort to maintain a safe workplace. Hazard identification. Supervisors and employees know how to identify hazards. Hazard control. Supervisors and employees know how to eliminate or reduce exposure to hazards. Accident and incident investigation. Accidents and near-miss incidents are investigated and their causes are prevented from happening again. Training. Employees learn safe work practices through training and instruction. Finally, evaluation. Business owners and managers evaluate their safety performances at least annually and use the evaluation to set new goals to improve performance. Part 3. Identifying and evaluating fall hazards. Here they have a more diagram picture. You can't probably see it from here, but it actually details with numbers and linkages of that to paragraphs that tell us exactly what is being done wrong in this picture. So it doesn't leave us out in the blue. It tells us exactly what's going wrong here. What is a fall hazard? A fall hazard is anything in the workplace that could cause an unintended loss of balance or bodily support and results in a fall. Fall hazards cause accidents such as the following. A worker walking near the edge of an unprotected and elevated floor trips over a protruding board. B, a worker slips while climbing an icy stairway with no handrail. C, a makeshift scaffold collapses under the weight of 4 workers and their equipment. Or D, a worker carrying a sheet of plywood on a flat roof steps into a skylight opening. How to evaluate your fall hazards? Involve others. You may need others to help you evaluate fall hazards. Ask workers who may be exposed to fall hazards and to their supervisors. Involving others also strengthens your safety program. Identify jobs that could expose workers to falls. Using a set of worksite plans, review the entire construction project. Evaluate each phase of the project from the ground up. Ensure that all walking/working surfaces have the strength to support workers and their equipment. Then identify jobs that could expose workers to falls. Determine how frequently workers will do jobs that expose them to falls. The more frequently a worker is exposed to a fall hazard, the more likely the worker could fall. Determine how many workers are exposed to fall hazards. As more workers are exposed to fall hazards, the more likely it is that one could fall. Identify any well, pit, shaft, or other similar excavation 6 feet or more in depth. Use guardrail systems, fences, barricades to protect any employee who might approach the edge of the well, pit, shaft, or other similar excavation when the excavation is 6 feet in depth or more. Fall protection for construction activities. Ensure that existing guardrails and covers meet subdivision M requirements. Find the requirements for guardrail systems in 1926.502b. Find the requirements for covers in 1926.502i. Identify fall hazards that you can't eliminate. If you can't eliminate fall hazards, you must ensure that someone who does fall doesn't die. There are two ways. Prevent falls with covers, guardrails, handrails, perimeter safety cables, and personal fall restraint systems, or control falls with personal fall arrest systems, positioning device systems, and safety net systems. Use these fail protection systems only when you can't eliminate fall hazards or prevent falls from occurring. Next, they have a table 2, fall protection trigger heights for construction. This is a very nice table as it lets us know exactly when we need to implement fall protection. I'm going to show you this one here, and I'm sure you can't quite read it, but I'll summarize. It has some columns, and it states that general fall protection is needed above 6 feet. This means that any work done over 6 feet from the ground needs to have general fall protection. Hoses and skylights, tripping in or stepping through into or through, need to be protected at any height. Excavations not readily seen should be protected when they exceed 6 feet in depth. The edge of a well, pit, shaft, or similar excavation falls under this. Above dangerous equipment, any height is necessary for fall protection. The list goes on and on, but I'm sure you can find that graph yourself. Part 4, supported access. Here we have another illustration. As you can see, this man is standing on the second to top ladder rung. That would be quite the violation of OSHA safety, indeed his personal safety. What is supported access? Portable ladders, supported scaffolds, and aerial lifts let you get to a work area and support you while you work. They make getting to work area easy, but can become fall hazards when not used properly. Portable ladders are versatile, economical, and easy to use. However, workers sometimes use them without thinking about using them safely. Each year, many construction workers in Oregon are injured when they fall from ladders, most less than 10 feet. The types of portable ladders. We use ladders to do all sorts of tasks, so it's not surprising that many types of ladders are available. Some commonly used are step ladders. Step ladder has flat steps, a hinged back, and is not adjustable. Used only on firm, level surfaces, available in metal, wood, or reinforced fiberglass. Must have a metal spreader or locking arm that cannot exceed 20 feet. Supports only one worker. Extension. Extension ladders offer the most length into general purpose ladder. Has 2 or more adjustable sections. The sliding upper section must be on top of the lower section, made of wood, metal, or fiberglass. Maximum length depends on material. Supports only one worker. Platform. Has a large stable platform near the top that supports one worker. Length cannot exceed 20 feet. How falls occur. Most workers fall from unstable ladders that shift or tilt when they climb too high or reach too far beyond the side rails. Workers also fall when they slip on the rungs they are climbing or descending when a vehicle strikes ladders. Required training. A competent person must train workers before they use ladders so they understand the following: the nature of the fall hazard in the work area, how to use, place, and care for ladders, maximum intended load carry capacities of the ladders, Oregon's OSHA requirements for the ladders they use. Scaffold supports, or supported scaffolds. A supported scaffold is simply an elevated platform that has a rigid means of support. Lay a board across a couple of tall buckets and you have a supported scaffold, but not a safe one. Many supported scaffolds used for construction work are complex structures, and workers must know how to erect them, dismantle them, and work safely from them. One of the many types of supported scaffolds, fabricated frame scaffolds, are the most common. Like portable ladders, they are versatile, economical, and easy to use. You see them on construction sites as single supported platforms and multiple platforms stacked several stories high on modular frames. Using a personal fall arrest system. Personal fall arrest systems must include a lanyard. Attach the lanyard to a vertical lifeline, a horizontal lifeline, or scaffold structure member that will hold at least 5,000 pounds. If you're not sure where to attach a lanyard, get training from a competent person. Protection for scaffold erectors and dismantlers. Workers must protect from falling 10 feet or more when they erect or dismantle supported scaffolds if protection is feasible and does not increase risk of a fall. A competent person must make the determination on case-by-case basis. Protection during storms and strong winds. Working from scaffolds is prohibited during storms or strong winds unless a competent person determines that it is safe, and the workers use personal fall arrest systems or are protected by windscreens. Safe practices. Getting to the scaffold platform. Use ladders or stairs to reach a platform that are more than 2 feet above or below the access point. Do not climb cross braces to reach a scaffold platform. Loading scaffold platforms. Scaffolds must be able to support their own weight and at least 4 times the maximum intended load. The maximum intended load includes workers, equipment, and supplies. Platforms must not deflect more than 1/60th of the span when they are loaded. Platforms must be fully decked or planked between the front uprights and the guardrail supports. Erecting, dismantling, and moving scaffolds. Scaffolds must be erected, dismantled, or moved only under the supervision of a competent person. The competent person must be on site to direct and supervise the work. Only trained, experienced persons selected by the competent person may do the work. Never use wood outriggers to support a scaffold. Don't use bricks, blocks, barrels, or other unstable objects to level scaffold. Don't use makeshift methods to increase the working height of the scaffold platform. Inspecting scaffolds. Inspect regular components, connections, planks, and structures. Keep the scaffold level, plumb, and square. Aerial lifts. Aerial lifts are designed to position workers and handle materials when a work surface is not easy to reach. Types of lifts. Most aerial lifts have an extensible or articulating mechanisms that can position workers up, down, or sideways. The American National Standards Institute defines and sets operating standards for 4 different types of aerial lifts. Vehicle-mounted elevating and rotating lifts are regulated by ANSI A92.2 devices. Manually propelled elevating work platforms are regulated under ANSI A92.3. Boom-supported elevating work platforms are regulated under ANSI A92.5 devices. Self-propelled elevated work platforms and scissor lifts are regulated by ANSI A92.6 devices. How falls occur. Most accidents involving aerial lifts can be traced to the untrained or improperly trained workers. Reasons for falls. Outriggers are not used or improperly placed and the lift vehicle overturns. Workers are not tied off when they are in the bucket. Workers fall or are pulled off the platform when the lift is struck by vehicles or moves unexpectedly. A hydraulic cylinder fails and causes the boom to drop. Table 3. Fall protection for aerial lifts. Vehicle mounts, elevating and rotating lifts, falling under ANSI A92.2 devices. Platforms other than buckets or baskets must include guardrail systems with guardrails, midrails, and toe boards. Each worker who has a boom-supported platform must use a personal fall arrest system or a fall restraint system that is rigged in such a way that the worker cannot fall from the hazard. Manually propelled elevating work platforms or ANSI A92.3 devices. The platform must have a guardrail 42 inches plus or minus 3 inches high, a midrail, and toe boards at least 4 inches high. Self-propelled elevating work platforms and scissor lifts falling under ANSI A92.6 devices. Safe practices. Keep in mind the following when you use an aerial lift. Use the lift only for its intended purpose and follow the manufacturer's instructions. Keep the operating manual with the lift. Keep the lift level and stable. Use outriggers and immediate stabilizers. Never move the lift when the boom is up and workers are on the platform, unless allowed by the manufacturer. Stand on the platform floor. Don't sit, stand, or climb on the edge of the basket, top rail, or mid-rail. Be sure to close the access gate while you are working from the platform. Inspect the lift before using it to make sure it is working properly and is in good condition. Know the lift's rated load capacity and don't exceed it. Stay at least 10 feet away from all electrical power lines. Never use the lift during severe weather. Use warning signs or barricades to keep others out of the work area. Never tie off to other equipment or to a structure next to the platform. Part 5. Suspended access. We're going to cover what is suspended access, adjustable suspension scaffolds, and cranes. We have another illustration here, as you can see. They appear to be cleaning some windows. What is suspended access? Portable ladders and supported scaffolds and aerial lifts provide easy access to most elevated work areas. When they are not feasible or safe, however, the alternative is a suspended platform. Suspended access is a means of getting to difficult to reach areas on a suspended platform. Usually the platform is an adjustable suspension scaffold. The scaffold, typically suspended by wire rope from a rooftop anchor, has a hoist that workers use to reach the work area. In some cases, however, even adjustable suspension scaffolds may not be feasible or safe. When there is no safe way to reach the work area, a crane or derrick may provide suspended access by hoisting a personal platform to reach the work area. Adjustable suspension scaffolds. A suspension scaffold is a temporary elevated platform that hangs by wire rope at a hoist to move up or down, and you have an adjustable suspension scaffold, but not necessarily a safe one. Suspension ropes, lifelines, platforms, hoists, overhead supported devices, and tieback systems are critical to the safety of adjustable suspension scaffolds. Basic type of adjustable suspension scaffolds include single joint adjustable scaffolds, a boat swing chair, 2-point adjustable suspension scaffolds, multiple point adjustable suspension scaffolds. Failing anchors also cause serious accidents. Too often, untrained workers attach lifelines and suspension ropes to secure-looking rooftops. Secure-looking, there are quotes there, so I'll put the air for you. Rooftop fixtures. For convenience, these anchors fail because they are not designed to support suspended loads. Lifelines can fail when workers hang them over unpadded edges, don't inspect them, or use ropes not designed for personal fall arrest systems. Required training. Those who work from adjustable suspension scaffolds must be trained to recognize fall hazards and to control or minimize the hazards. Training must cover the following topics: scaffold load capacity and types of load appropriate for the scaffold. When fall protection is required, the appropriate protection of use and how to use it. How to use scaffold components, how to reach access areas, how to protect those below from scaffolds or falling objects. How to avoid electrical hazards. Table 4, safe practices for working from adjustable suspension scaffolds. This is a general flowchart that will illustrate exactly how to utilize it. What you should know about descent control devices. A descent control device lets you descend a primary support rope, typically from a boat swing chair, and then lock the device when you reach the work area. The device works by friction, engaging the support rope and controlling descent speed. Most workers start from the roof and work down to the surface of the building. When they reach the ground, they remove the descent equipment from the support rope and return to the roof for another drop. How falls occur. Most falls happen when the primary support rope or a supporting anchor fails, not the descent device. Support ropes fail because workers don't regularly inspect them or they misuse them. Anchors fail when workers simply assume they are secure. Descent devices, support ropes, and anchors rarely fail when workers know how to use them. Oregon OSHA requirements. Oregon OSHA does not have specific requirements for descent control devices. However, you should follow the manufacturer's instructions and be trained by a competent person. Crane and derrick suspended personal platforms. Sometimes, workers may not be able to reach the work area with stairways, ladders, scaffolds, or aerial lifts, and there is no other way to reach the area than to use a crane or derrick for a personal platform to lift workers to the area. Employee safety must be on a basis for your decision and use this method. See Subdivision CC Cranes and Derricks in Construction 1926.1431 Hoisting Personnel for more information. How injuries occur. Workers rarely fall from suspended personal platforms. Most incidents occur when the boom or other part of crane connects an energized power line. Other causes of serious incidents include instability, lack of communication, rigging failure, or boom failure. Safe practices for riding personnel's platforms to the work area. Conduct a pre-lift meeting to review the applicable requirements of 1926.1431 and the procedures will be followed. Conduct a trial lift with an unoccupied platform loaded at least to the anticipated lift weight from where employees will enter the platform to each location, at which point the platform is to be hoisted and positioned. Conduct a visual inspection of the equipment, base, support, and ground, and personnel platform to determine if the lift has exposed any problem or procedure produced an adverse effect. Stay within the platform while it is moving and use fall arrest systems with a lanyard connected to the structural member of the platform. Stay in view of the crane operator or signal person while you are on the platform. Before leaving the platform for the work area, secure it to the structure. We're now entering part 6, preventing and controlling falls. This is where we're going to get down to the nitty-gritty and the real meat of what this operation is all about, stopping people from falling. And as you can see, we have a picture now of some workers assembling some railings. You notice it has the headboard, the toe board, and the center board. That's a proper use for them to protect themselves. What is a fall protection system? A fall protection system is designed to prevent falls or control them, so that someone who does fall doesn't die. If workers will be exposed to fall hazards that you can't eliminate, you need to protect them with one of the fall protection systems shown in Table 5. And Table 5 is a little flowchart, again, that shows us the type of hazard we may be exposed to and the following safety requirements for that type of hazard. Other fall protection methods. The following methods may be appropriate for preventing falls: safety monitoring for roofing work, catch platforms, and cover holes. Simple and effective when they are capable of supporting, without failure, at least twice the weight of employee equipment materials that may be imposed on the cover at one time and are properly installed. Rigid covers prevent workers from falling through temporary holes opening to skylights and walking/working surfaces. And lastly, fences and barricades. What to consider when selecting a fall protection system. Appropriate fall protection systems have the following characteristics. They are affordable. They offer the least interference with workers' tasks or activities. They prevent falls or protect workers who do fall. Whenever possible, eliminate fall hazards. Personal fall arrest systems. A personal fall arrest system consists of an anchorage, connectors, and a full body harness that work together to stop a fall and to minimize the arrest force. Other parts of the systems may include a lanyard, a deceleration device, and a lifeline. The personal fall arrest system is effective only if you know how all of the components work together to stop a fall. Before you use a personal fall arrest system, you should know the following: how to select and install anchorage, how to select and use connectors, how to put on and use full body harnesses, how to correctly attach and use the lanyard, when a deceleration device is necessary, how to erect and use a lifeline, the correct procedure for using retractable devices, how to estimate fall distances, how to avoid swing falls, how to inspect and maintain the system, how you will promptly be rescued if you fall. The anchorage. The anchorage is a secure point of attachment for lifelines, lanyards, or deceleration devices. An anchorage for a personal fall arrest system must support at least 5,000 pounds. Anchorage that can't support 5,000 pounds must be designed and installed under the supervision of a qualified person and must be able to maintain a safety factor of at least 2. That equals twice the impact force of the worker free falling 6 feet. If you don't know how much weight an anchorage will support, have a qualified person check it before you trust your life to it. Connectors. An anchorage, a lanyard, a body harness are not useful unless they are linked together. Connectors do the linking, and they make the anchorage, the lanyard, or the harness a complete system. Connectors include carabiners, snap hooks, and D-rings. Carabiner, a high tensile alloy steel connector that has a locking gate that is used mostly in specialized work such as window cleaning and high angle rescue. Carabiners must have a minimum tensile strength of 5,000 pounds. Snap hook. A snap hook shaped member is a keeper that opens to receive a connecting component and automatically closes when released. Snap hooks are typically spliced or sewn into lanyards and self-retracting lifelines. Snap hooks must be high tensile alloy steel and have a minimum tensile strength of 5,000 pounds. D-ring. D-rings are the attachment points sewn into the full body harness. D-rings must have a minimum tensile strength of 5,000 pounds. The full body harness. The full body harness has straps that distribute the impact for fall over the heights, for fall over the thighs, waist, chest, shoulders, and pelvis. Full body harnesses come in different styles, many of which are light and comfortable. Before you purchase harnesses, make sure they fit those who will use them. They're comfortable and they're easy to adjust. Lanyards. A lanyard is specifically designed flexible line that has a snap hook at each end. One snap hook connects to the body harness and the other connects to the anchorage or lifeline. Lanyards must have a minimum breaking strength of 5,000 pounds, and they come in a variety of styles, including self-retracting types that make moving easier and shock-absorbing types that reduce fall arrest forces. Deceleration devices. Deceleration devices protect workers from the impact of a fall and include shock-absorbing lanyards, self-retracting lifelines or lanyards, and remote grabs. Shock-absorbing lanyard. A shock absorber reduces the impact of a worker during fall arrest by extending up to 3.5 feet to absorb the arrest force. Subdivision M rules limit the arrest force to 1,800 pounds, but the shock-absorbing lanyard can reduce force even more, to about 900 pounds. Because a shock-absorbing lanyard extends up to 3.5 feet, it is critical that the lanyard stops the worker before the next lower level. Allow about 20 vertical feet between the worker's anchorage point and the level below the working surface. Always calculate the total distance of the position fall before using a shock-absorbing lanyard. Consider the following example. How to calculate total fall distance. Lanyard length equals 6 feet, plus deceleration distance, 3.5 feet. Worker's height, 6 feet, plus a safety margin of 2 feet. This equals 17.5 vertical feet from anchorage to lower level. Never use a shock-absorbing lanyard if the shock absorber is even partially extended or the lanyard has arrested a fall. Lifeline. A lifeline is a cable or rope that connects to a body harness, lanyard, or deceleration device in at least one anchorage. There are two types of lifelines, verticals and horizontal. Vertical lifeline. A vertical lifeline is attached to an overhead anchorage and must be connected directly to the worker's full body harness, lanyard, retractable device, or grab rope. It must have a minimum braking strength of 5,000 pounds. When the worker needs to move horizontally, however, a vertical lifeline can be hazardous due to the potential of a swing fall. The pendular motion that results when the worker swings back under the anchorage point. A swing fall increases the worker's risk of striking an object or a lower level during the pendulum motion. Horizontal lifeline. Unlike a vertical lifeline, the horizontal lifeline stretches between two anchorages. When you connect a lanyard or rope grab to the horizontal lifeline, you can move much greater loads than a vertical lifeline. Horizontal lifelines can fail at the anchorage points if not used or installed correctly. For this reason, horizontal lifelines must be designed, installed, and used under the supervision of a qualified person. Horizontal lifelines and sag angles. Any load on a horizontal lifeline will cause it to deflect or sag. A sag angle is a horizontal lifeline's angle of deflection which is subjected to a load such as a falling worker. Reduce the sag angle, making the horizontal lifeline too tight, actually increases the force of the line during the fall. As you tighten a horizontal lifeline, you dramatically increase the impact load. For example, when the sag is at 15 degrees, the force on the lifeline and anchorage subjected to the load is 1 to 2. However, if you decrease the sag angle to 5 degrees, the force is about 6 to 1. To reduce loads on a horizontal lifeline, increase the sag angle or connect a lifeline with a shock-absorbing lanyard. Personal fall restraint systems. Unlike the personal fall arrest system, which is designed to stop a fall, a personal fall restraint system prevents a worker from reaching an unprotected edge and thus prevents a fall from occurring. This system consists of an anchorage, connectors, and a body harness or a body belt. The attachment point of the body belt or full body harness can be at the back, front, or side D-rings. The anchorage for a fall restraint system must support at least 3,000 pounds and be designed and installed by a qualified person and have a safety factor of at least 2. Guardrail systems. Guardrail systems consist of a top rail, mid rail, and intermediate vertical members. Guardrail systems can also be combined with toe boards that prevent materials from rolling off the working/walking surface. Guardrail systems must be free of anything that might cut a worker or snag a worker's clothing. Top nails and mid rails must be at least 1/4 inch thick to reduce the risk of hand lacerations. Steel and plastic banding cannot be used for top rails and mid rails. Other requirements for guardrails. Wire rope used for top rail must be marked at least every 6 feet with high visibility material. The top rail of a guardrail must be 42 inches, plus or minus 3 inches above the walking surface. The top edge height cannot exceed 45 inches if the system meets all other performance criteria. Mid-rails must be installed midway between the top rail and the walking working surface unless there is an existing wall or parapet at least 21 inches high. Wall openings. Each employee working on, at, above, or near wall openings, including those with chutes attached, where the inside bottom edge of the wall opening is less than 39 inches above the walking surface, and the outside bottom edge of the wall opening is 6 feet or more above the lower levels, must be protected from falling by use of a guardrail system, safety net systems, personal fall arrest systems, or personal fall restraint systems. A simple method to protect employees from falling through such openings is to use available framing materials as guardrail that is capable of withstanding force without failure, and a force of at least 200 pounds in any outward or downward direction. At any point along the top edge height of the top rail must be 42 inches plus or minus 3 inches to the walking surface. Safety net systems. Safety net systems consist of mesh nets and connecting opponents. Safety net openings can be more than 6 inches on a side, center to center. Safety nets must not be installed more than 30 feet below the working surface. An installed net must be able to withstand a drop test consisting of a 400-pound sandbag 30 inches in diameter dropped from the working surface. Inspect nets regularly and remove debris from them no later than the start of the next work shift. Warning line systems for working roofs. Roofing works refers to hoisting, storing, applying, or removing roofing materials and equipment. Roofing work includes work on related insulation, sheet metal, and vapor barriers, but does not include construction of the roof deck or leading edge work. A warning line system for roofing work consists of ropes, wires, or chains, and supported stanchions that mark off the area while roofing work can be done without guardrails, personal fall restraint systems, or safety nets. Warning line systems can only be used for roofing work on roofs that have slopes of 2 and 12 or less, vertical or horizontal. The purpose of the line is to warn roofers that they are near an unprotected edge. A warning line must be at least 6 feet from an unprotected edge and meet the following criteria. Be flagged at least every 6 feet with high visibility material. Be rigged so that the line is 34 to 39 inches from the working surface. Have a minimum tensile strength of 500 pounds. Don't use plastic caution tape for warning line. Be attached to each stanchion so that the tension at one section of the line will not cause an abject stanchion to tip over. Stanchions must be able to support a force of at least 16 pounds applied horizontally and the direction of the roof edge without tipping over. Those who do roofing work between the warning line and the unprotected roof edge must be protected with personal fall arrest systems, fall restraint systems, guardrail systems, safety monitoring systems, or safety nets. Warning lines for non-roofing construction activities. Construction trades that don't do roofing work can use warning lines similar to those allowed for roofing work. However, non-roofing work warning lines only alert workers who are approaching an area when unprotected fall hazards exist and are not considered a fall protection system. Setting up. Non-roofing work warning lines also differ from warning lines used by roofers when they are set up. A setback distance for non-roofing warning lines must be far enough back to prevent worker exposure to fall hazards. When determining the appropriate setback distance, factors such as, but are not limited to, weather, visibility, the slope, condition of the work surface, the work performed, materials handled, workers' experience, and supervision must be considered. Safety monitoring for roofing work. This system uses a person/safety monitor rather than a mechanical system to warn roofers that they are in danger of falling. The safety monitor, who must be a competent person, is responsible for recognizing fall hazards and warning workers around them. Safety monitoring can be used only to protect those who do roofing work on roofs that have slopes no greater than 2 and 12 widths, no greater than 50 feet. Safety monitoring on roofs wider than 50 feet is not permitted unless a warning line system also protects the workers. The safety monitor's responsibilities include recognizing fall hazards, warning workers when they are unaware of hazards or are working not safely, staying on the same working surface as the workers to watch them and to communicate with them while they are working, avoiding any other work or distracting activity while they monitor the workers. Only those who are doing roofing work are permitted in the area controlled by the safety monitor. Mechanical equipment can't be used or stored in the area. Covers for holes. Plywood hole covers. Heavy plywood is a common choice for covering temporary holes in roofs and floors, but plywood strength and durability can vary. Some materials, including plywood scraps from shipping crates or similar scrap products, do not have the structural value or span ratings, making it hard to know if they are strong enough. In addition, strength information on the plywood is occasionally covered with paint. Plywood is susceptible to damage over time from exposure to water, traffic, and heavy loads that may reduce its strength. Some indicators of reduced strength plywood may include cracks, chips, a warped appearance, a worn surface, delamination, and water stains. Expected damage after exposure to water depends on whether the plywood is exterior grade or interior grade. The binding agents, i.e. adhesive, used to adhere interior grade plywood's layers degrade more rapidly in a moist environment than do the binders used in exterior grade plywood, protecting workers from falling objects. Be aware of those working above and below you. Protect yourself and others from falling objects with one or more of the following methods: canopies, tow boards, panels and screens, barricades, and fences. When hard hats are required. Workers must wear hard hats when their job exposes them to falling objects. In addition, employers must do one of the following to reduce employees' exposure to objects that could fall from upper levels: erect tow boards, screens, or guardrail systems on upper levels to prevent objects from falling. Build a canopy over workers to prevent falling objects from striking them. Erect a barricade that prevents workers from entering an area where they could be exposed to falling objects. We're now entering Part 7, training workers about fall protection. We have a nice little picture here of these workers being trained, I would assume, about the dangers of many things. Why train workers about fall protection? Workers need to know about the workplace hazards they may be exposed to, how to recognize the hazards, and how to minimize their exposure. The best way for them to learn is through training. Training ensures that they know the hazards and can demonstrate how to protect themselves from falling. Some employers assume that they can train their employees simply by showing them on a fall protection training video or giving them a safe practice guide. Even this one. But this is not training. Required training for workers exposed to fall hazards. The trainer must be a competent person. Recall that a competent person is one who can identify worksite hazards and who has management authority to control them. The trainer must know and be able to explain the following: the nature of fall hazards on the worksite, procedures for erecting, maintaining, and dismantling fall protection systems, how to use and operate fall protection systems, a role of each employee who may be affected by safety monitoring system, a restriction that applied to mechanical equipment used during roofing work, the procedure for handling and storing materials that are for erecting protection from falling objects, the application requirements of subdivision M for the type of fall protection systems used. When to train. Employees must be trained before they begin a task that could expose them to fall hazards or before they use fall protection systems. They must be retrained when they don't recognize fall hazards and when they don't follow safe practices for using fall protection systems, and when changes in the workplace or in the fall protection systems used make their previous training incomplete or obsolete. What to put in writing. Keep a record of each employee's fall protection training, including the employee's name, the training date, the trainer's name, record the information, on a simple form like the example in Tablet 7. Tablet 7 here is just a ledger that shows Jim Smith, Art Smith, Miles Smith, Peggy Smith, Mary Lou Smith, and Yansis Smith. And it just shows a signature type. So you can see that there. They just wrote those signatures there. So that's how you would do it if you were an employer. So you keep track of it. We're down to Part 8, maintaining equipment. This is some nice little stuff. So you can see the D-ring is not functioning correctly, and the fall protection rope seems to be having some frayed areas on it. So we can see clearly that we have issues here with these equipment. Inspecting equipment. Pay attention to the condition of your equipment. Inspect it frequently. Keep it clean and store it properly, and it won't let you down. Inspect fall arrest, fall restraint, and positioning device systems every time before you use the personal fall arrest, restraint, or positioning device system. Inspect the components for damage or excessive wear. Replace any component that looks damaged. Don't use a personal fall arrest system that has arrested a fall unless a competent person has determined that the system is safe to use. Table 8. Inspecting harnesses, lifeline, and anchorage. What to look for in harness webbing. Frayed edges, broken fibers, pulled stitches, cuts, burns, and chemical damage. Harness D-rings. Look for cracks, breaks, rough or sharp edges. The D-ring should pivot easily. Harness buckles. Excessive wear, frayed or cut fibers, and broken stitching. Harness grommets. Loose, bent, or broken grommets and punched holes that may not be made by the manufacturer. Lifelines. Wear or deterioration. Anchorage and anchorage connectors. Look for abrasion and damaged threads or swages. Inspect stitching and loops on the synthetic slings for cuts, cracks, and frayed or broken stitching. Look for excessive kinks or damaged steel fibers. Snap hooks. Look for cracks, excessive wear, and corrosion. Snap hooks should open easily and close firmly. Keeper locks must prevent the keeper from opening when it is closed. Lanyards. Inspect before use. Table 9 shows what to look for. With the type of lanyard, wire rope lanyards, look for cuts, frayed strands, or excessive wear. With a web lanyard, look for cuts, decoloration, cracks, frayed, or broken stitching. With a rope lanyard, look for frayed or cut fibers. The entire length of the rope should have the same diameter. With a shock-absorbing lanyard, look for cuts, discoloration, cracks, frayed or broken stitching. Remove a lanyard from the service if any part of the warning label is exposed. Summary. Inspecting, cleaning, and storing equipment. Inspecting equipment. Follow manufacturer's instructions and warnings. Inspect equipment before using it. Look for damaged or missing parts. Labels, warnings, and other instructions, they should be legible. If equipment looks like it needs repair, remove it from the service and have a competent person examine it. Have a competent person regularly inspect all equipment. Mark equipment with unique code or item number. Identification numbers make it easier to keep track of the equipment and document maintenance or repair. Cleaning equipment. Wash synthetic rope or body harnesses in soapy water to remove dirt. Rinse them with clean water. Air dry at room temperature. Don't lubricate moving parts unless the manufacturer requires it. Lubricants attract dirt. Don't remove information labels and warnings. Make sure they are still legible after cleaning. Storing equipment. Follow manufacturer's instructions for storing equipment. Store equipment in an area that is clean, dry, and moisture-free. Avoid excessive heat, light, oil, and corrosive chemicals. Part 9. Responding to falls. Here we can see that there is a man who's being taken away in an ambulance. We can assume that he was taking a fall here. So we're going to figure out what we're supposed to do there. Prompt rescue required. The best strategy for protecting workers from falls is to eliminate the hazards that can cause falls. If you can't eliminate the hazard, you must protect workers with an appropriate fall protection system or method. If a worker is suspended in a personal fall arrest system, you must provide a prompt rescue. Prompt means immediate. A worker suspended in a harness after a fall can lose consciousness if the harness puts too much pressure on arteries. A worker suspended in a body harness must be rescued in time to prevent serious injury. If a fall-related emergency could happen at your worksite, you should have a plan for responding immediately. Workers who use personal fall protection systems must know how to promptly rescue themselves after a fall, or they must be promptly rescued. Identify critical resources and rescue equipment, first aid supplies, and rescue equipment. Train on-site responders, establish a chain of command, establish a procedure for responding to emergencies. Summary: responding to falls. Before on-work site begins, identify emergencies that could affect your worksite. Establish a chain of command. Document procedures for responding to emergencies and make sure they are available at the site. Post emergency responder phone numbers and addresses at the worksite. Identify critical resources and rescue equipment. Train on-site responders. Identify off-site responders and inform them about any conditions on the site that may hinder a rescue effort. Identify emergency exit and exit codes. Make sure responders have quick access to rescue and retrieval equipment such as lifts and ladders. During on-site work, identify an on-site equipment that can be used for rescue or retrieval, such as extension ladders and mobile lifts. Maintain a current rescue equipment inventory at the site. Equipment may change frequently as the job progresses. Reevaluate and update the emergency response plan when on-site work tasks change. When an emergency occurs, first responders should have a clear path to the victim. Others should direct emergency personnel to the scene. You can use 911 for ambulance service. However, most 911 responders are not trained for rescue of worker. Make sure only trained responders attempt a technical rescue. Prohibit all non-essential personnel from the rescue site. After an emergency. Report fatalities and catastrophes to Oregon OSHA within 8 hours. Report work-related injuries or illness that cause the loss of an eye, an amputation, or avulsion that includes bone or cartilage loss in an inpatient hospital for medicalized treatment other than first aid to Oregon OSHA within 24 hours. Identify equipment that may have contributed to the emergency and put it out of service. Have a competent person examine equipment if the equipment is damaged, repair, or replace. If the equipment caused the accident, determine how and why. Have a document in detail the cause of the incident and describe how it can be prevented from happening again. Review emergency procedures, determine how the procedure could be changed to better handle similar events, and revise the procedures accordingly. We're now on to Part 10, an overview of Subdivision M. And here we have a very nice picture. I can show you all the, looks like they're standing trusses on a stick frame there. About Division M, Subdivision M. Subdivision M, which covers Oregon OSHA fall protection requirements for the construction industry, has 4 parts: scope, application, and definitions, located in 1926.500. Duty to have fall protection. Fall protection systems, criteria, and practices fall under 1926.502, 437-003-0502, 437-003-1502, and 437-003-2502. Training requirements are located in 473-003-0503. Also included in Subdivision M are 4 non-mandatory appendices. Guidelines for complying with safety monitoring systems and working. That's Appendix A. Guidelines for complying with guardrail systems. Appendix B. Guidelines for complying with personal fall arrest systems. Appendix C. Guidelines for complying with position device systems. Appendix D. Duty to have fall protection. The requirements in 437-003-1501 parentheses 1 establishes the general fall protection requirement for workers who walk or work at heights at 6 feet or higher when performing construction activities. Table 10. Fall protection requirements not covered in Subdivision M. This is working from scaffolds, cranes and derricks, crossing and excavation, structural steel erection, tunneling operations, working on electrical transmissions or distribution lines. Training requirements. The requirements in 437-003-0503 cover workers who may be exposed to fall hazards. Training programs. Workers must be trained to recognize fall hazards and to know procedures that minimize the hazards. Certificate of training. Each employee's name, training date, and the trainer's signature must be documented in the training record. Retraining. Employees must be retrained when they don't recognize fall hazards, when they don't follow safe practices for using fall protection devices, and when changes in the workplace or fall protection systems used make their previous training obsolete. There are now notes available, so if you wanted to, in this booklet, you could write in some notes, perhaps reference pages so you would know exactly where to locate all this. And then in the back we have fall protection for construction activities. So there's phone numbers for the enforcement, consultative services, standards and technical resources, the appeals, the conferences, and the public education. This concludes the reading of the 2019 Fall Protection Handbook from OSHA. And this one was issued from the Salem Central Office, which is the capital of Oregon, which obviously is where this one's read. Thank you so much for tuning in, and I hope you learned something here.